Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong. My name is Cody J. Brown, and I will be moderating today's session. We have an exciting presentation ahead of us, but before we begin, I have just a few housekeeping notes. Today's event is being recorded, so if you miss any or all of the discussion, it will be made available to rewatch. You will receive an email after the webinar concludes with a link to access the on-demand. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We'll try to address as many questions as you can send in, so please get them in early. We also encourage discussion by using the chat tab. Let us know your thoughts, questions, comments, concerns, or just say a quick hello. And also, please keep an eye out for our polls, as we have 3 polls that will come out during the duration of today's presentation. Finally, at the end of the webinar, we have a drawing for 4 $25 Amazon gift cards, so stick around to see if you're one of our 4 lucky winners. Let's go ahead and kick off our webinar for today. Our topic is Fixing Hard-Coded Secrets the Developer-Friendly Way. And I'm joined today by Ronan Slavin, co-founder and CTO at skyrocketing, and Andrew Fife, Vice President of Marketing at skyrocketing. Ronan and Andrew, thank you so much for being here with us today. I'm now going to turn my webcam off and turn the floor over to the two of you.
Cody, thank you so much for the introduction. So we're here to talk about an extremely important topic, which is finding hard-coded secrets. And not only is this an important security issue, but it's an issue that can become a little bit thorny between teams. It is security asking the development team to do a little bit more work. And so finding ways in which that we can detect secrets and remediate secrets in a way in which developers are going to be more willing to do the work, that's a little more friendly to their workflows, is very important. So that being said, my name's Andrew Fife. I run marketing for skyrocketing. I've been marketing for security and IT companies for approaching 20 years now. Most recently was at a SaaS company called Shift Left, and before that at Okta. So that's a quick overview on my background, which probably isn't nearly as interesting as our CTO and co-founder, Ronan Slavin. Ronan, would you like to tell everyone a little bit about yourself?
Yeah, thanks, Andrew. Hey, everyone. I'm Ronan Slavin. I'm the CTO and one of the founders here at skyrocketing. Basically, I've been involved in cybersecurity for the past decade. Before founding skyrocketing, I was the head of research at Reason Cybersecurity, which acquired my previous startup that was called Firelock, where we built a solution to protect data even after a device is compromised. Before that, I worked at both offensive and defensive cybersecurity companies, and I was at the 800 elite cybersecurity unit in the Israeli Defense Forces.
All right. So what are secrets in code? There are 3 main things, 3 main categories. Predominantly it is authentication. That's what we see the most. So that can, of course, be a username and password. It could be authentication tokens or API keys. We do see some encryption, and then, of course, there are a very wide bucket of custom secrets that we that we see a little less frequently. But it is interesting to note that GitHub is increasingly being used by more and more organizations or individuals in almost a Dropbox-like fashion. So it's amazing what you can find in GitHub these days. And if you're ever interested to see, things that people are finding in GitHub that you wouldn't expect, GitHub does actually maintain a Digital Millennial Copyright Act takedown request folder. So if you go to github.com/github/DMCA, you can look up and see all the things that people are requesting to be taken down. And it's a really great example. I mean, yes, there's a lot of source code leakage in there. That's probably predominant, but people are hosting media files, game cheat codes, activation keys, all kinds of stuff. So it really, it really runs the gamut. Why are secrets increasing? I mean, there's a very simple answer to this, and that is that the way in which we're building applications today requires a heck of a lot more authentication. So whether you're using an API and therefore that creates a need for an API key, or you've simply developed in a more microservice-based architecture, you're leveraging infrastructure as code, which is creating more internal and authentication needs into things like an S3 bucket, or what have you. The point is that there are multiple forces that that are driving the increase in needs for authentication within modern development. I think it's fair to say that the need for secrets is actually skyrocketing. Um, but this is a big problem. It's a big problem because whatever you whatever you assume in security is secure ultimately will become insecure. And so the reason why, or one of the reasons why we've relied on hard coding secrets directly into code is because we've assumed that that code will never be exposed. Um, but that turns out that's not a very good assumption. And in fact, attackers today are specifically looking for secrets in code because they facilitate wider lateral movement. Uh, it's a pretty simple concept, but obviously, if I've got a username and password stored into an S3 bucket in my code, and an attacker finds that code and they find those credentials, well, now they can get straight into the data that's stored in that database. And not only is this an issue when it comes to um, facilitating lateral movement, but if you think about it, it's also a compliance violation. Now, I want to be realistic here, right? We today are not seeing a lot of companies fail audits based on hard coded secrets, but I think in the future that's going to come because if you think about it, that same S3 bucket or that same username and password that gets me into the S3 bucket, well, why is that in the source code? And does everyone that has access to that repository need access to that S3 bucket? I mean, in a large enterprise, the answer is, very few people that have access to that source code would actually need access to the S3 bucket. So we're eliminating that separation of duties, which is core to almost every modern, compliance regulation, whether it's SOC 2 Type 2 or something more industry specific like PCI or FedRAMP or ISO 27001. I mean, all of these have some way to address separation of duties. So I think from a compliance perspective, compliance regulations always lag behind the actual technical reality. So I think it's fairly safe assumption to say that in the next couple of years, hard-coded secrets are going to start causing organizations to fail audits. But the big issue is that the way in which not only do we use secrets more commonly, but the exposure of them is actually becoming more common. There are two primary reasons for this. The first primary reason is that because attackers have come to understand the importance of secrets, they're now specifically targeting developer accounts, trying to compromise developer accounts in order to get secrets from the organization. Developers tend to have wide-ranging access. They tend to have, both in terms of lots of systems, but also in terms of authorization within individual systems. So if you can breach one developer's account, more than likely you're going to be able to get access to lots of repositories and lots of other locations within the SDLC that have those secrets. And then, of course, source code leaks is the other very big one that we see. When you think about GitHub's identity model, it's wonderful for developers that I'm aware of anyway. GitHub is probably the only enterprise tool that has a user-centric identity model. I mean, you take your GitHub identity and then your organization grants you access into their repositories. Whereas if you think about your corporate email account is centered based on the company, and you have access to it for the limited time period in which you are employed or otherwise working for the company in some capacity. Well, so as wonderful as this GitHub model is, most developers tend to be pro open source, and so most developers tend to have their personal accounts defaulted to being open. So now we've created a situation where I can easily leak that source code simply by saving it in the wrong location. A small fat finger can have a huge impact on an exposure for the company. I mean, nothing worse than literally having your secret exposed publicly. And then, there's malicious insiders and semi-malicious insiders. I mean, thankfully, malicious insiders, while very dangerous, tend to still be somewhat rare. What we are seeing bigger increase in is semi-malicious insiders, and that is, you might have heard of the term of the Great Resignation that's been happening, where so many people in the pandemic are choosing to resign from their job for various reasons. Well, it turns out that when people are leaving their job, they also tend to feel more entitled to take with them things that they've worked on. So this employee churn that's really increased has led to an increase of 3x of employees taking source code that they've worked on with them. Now, the reason why I call this semi-malicious is because thankfully, in most cases, people aren't leaving with bad intent. But regardless of why I take your source code, it is still theft. And who knows how I might store that code, once I've taken it outside of the organization's source control management system. And how much do I emphasize security in how I do that? So we think that semi-malicious insiders are actually, just kind of like the inadvertent source code leaks. Not necessarily somebody who's trying to do something bad to hurt your organization, but often somebody who will actually do something that hurts your organization. So it can be a pretty big problem. And of course, I mentioned GitHub's DMCA takedown notices. We only have this data from 2015 to 2019, but you can see that there's really a significant and steady increase here. And I think we all know the headlines from 2020 and 2021, whether it's Nintendo or Mercedes or Boeing or Microsoft themselves, the state of New York. I mean, just over and over and over again, we're seeing that secrets are being exposed, codes being exposed through leakage. And there've been a ton of incidents that have involved secrets. So we don't know the exact role that secrets played in SolarWinds attack, but we do know that SolarWinds themselves had some secret exposure issues. This, for example, you can see that SolarWinds left some fairly risky information online. We know that in the results of the SolarWinds incidents, as the attackers breached Microsoft, Microsoft was able to forensically determine that the hackers were looking at their source code for secrets in particular. So not only did secrets likely play a role in how SolarWinds itself was compromised, but once they were able to move into SolarWinds customer environments, they were continuing to look for more secrets there. CodeCov, CodeCov was breached because they had a secret exposed, and then the tampering of their code that occurred was actually, once the code was in the customer's environment, it was also looking for secrets. So again, this is an example of one secret breach where then attackers were understood the importance of secrets, and so we're looking for more of them. We had New York State misconfigure their, I think it was their GitLab instance, and they allowed it to be accessed publicly. And in addition to that, they had very little in terms of least privilege policies. So you could actually log into you could reach their GitLab server, and you could create your own account, and you could give yourself access to whatever you wanted. And of course, it turns out that they themselves also had secret keys and passwords, as you can see down here. So we don't know that was actually exploited, but it certainly was exposed. And then, of course, Amazon and Uber had extremely large hacking incidents where effectively what happened was, it's the inadvertent exposure case where developer mistakenly saved proprietary source code um, in their personal repository, and that personal repository was set to public. So therefore, in Uber's case, they literally lost 57 million records because somebody noticed legitimate AWS administrator credentials that were in this developer's public repository, and they started the attack simply by logging in with legitimate credentials. Not only is this theoretically important, there's lots and lots of incidents to show that hard-coded secrets are not only the source, the start of attacks, but also, facilitate deeper and wider attacks. So with that, we'd like to move into our first poll question. Cody, do you want to fire the poll when you have a sec?
Sure. So I've just opened the poll. And it reads, what causes you to lose the most sleep about hard-coded secrets? A, exposure via source code leaks. B, exacerbating existing attacks. C, compromised insider accounts. D, malicious insiders. Or E, compliance violation.
Well, Cody, how are the responses looking? Should we give people, a little more time?
So we currently have 27 responses. But so far, the percentage makeups look like we have a tie between choices A and C, each at 29% of the vote. And the rest of them are in a three-way tie at 14% of the vote. So it looks like we've got two that take the lead a little bit, and the rest are pretty even across the board.
Okay, and actually, we can't see the results on our end. So, could you remind us again which two were the lead?
Yes, sorry. So A, exposure via source code leaks, and C, compromised insider accounts are our top two choices.
Okay, yeah, that's that's kind of what I expected to see. People are more, it's obviously more scary that somebody would come in would get let into your account because we think because we all tend to assume that that our organizations are pretty hard, and so therefore less likely that there's somebody already in our account or within our systems. Um, so that makes sense there. But I guess I would just always encourage everyone to be thinking about, that lateral movement, because once somebody gets in, hard-coded secrets can let somebody move from A to B very, very quickly. Ronan, do you have any thoughts on that before we move on?
Yeah, I think I'm on the same page with you. It's also what I expected. Basically, there's this inherent trust that we give these keys. So exposing them via code leaks or having a compromised insider account with these keys on them would give the attacker the same access. So yeah, I agree.
Cool. All right. So shall we flip back to slides, Cody?
Go for it.
Okay. So can the viewers see my slides?
They sure can.
Great. All right. So moving on. we wanted to propose a security or hard-coded secrets maturity model. Um, all organizations, or most organizations need to address hard-coded secrets, but what's sort of the order in which you should think about addressing things, and and where are we all at within our various journeys? So the first step of this really is awareness, right? And it's understanding that there is a need. I mean, not all organizations have adopted modern software development practices. It might just be that that for whatever reason their business started developing an app that we might refer to as in a legacy model, and there hasn't been a need to update it. So, you know, but recognizing that your organization is now rapidly increasing the need for authentication, that's step one. Um, Recognizing that you probably do have some hard coded secrets, but you really don't understand the severity of it yet. Um, you may have put some training or a policy in place, but you don't have any way to detect whether or not that policy is being abused, and you certainly don't have any ability to enforce or block violations. So that's phase one, is awareness. Phase two is basic detection. So we would describe basic detection as you have a secret scanning tool and you've got it focused on the main branch. So you are scanning the code repository. You're looking for common formats, and your scans are not based on how your SDLC is progressing. They're not triggered based on certain things within the SDLC. They're either time based, meaning you've got like a quarterly scan that you do, or they're just simply ad hoc. So that's what we would describe as basic detection. And from our purview, this is where most organizations sit um, in this basic detection bucket. Um, we do think that you can advance this. Advanced detection. One of the biggest pieces is that secrets can live in so many more places throughout your SDLC than just the main branch. I mean, simply within the source control management system, there's version history. Lots of organizations mistake that. And then there's also new commits and ultimately pull requests. Some organizations have infrastructure as code in unique repositories, and there can absolutely be secrets in infrastructure as code, just like there can feature or source code. So that's another thing to consider. We mentioned the personal repositories of developers. We don't think that many people are doing it maliciously, but understanding what your developers are saving in their personal accounts and whether or not any of your organization's secrets are there is vitally important. Um, Build logs, as well as your cloud environment, um, can also have secrets. So if you're focusing your secrets only on a small part of the SCM, then there's quite a lot of other secrets potentially within your organization that you might be missing. The second thing is, what are you scanning for? And although most scanning tools that we've seen are going to do, are going to be able to find some of the authentication related secrets, especially if your organization has custom secrets, are you able to actually find all of the secrets that are important to your organization, with that tool? And then lastly, but ironically, not leastly important, is prioritization. So you want to be able to give your developers an idea of how important is this secret and what should I worry about fixing first. In an ivory tower, we can sit here and say any vulnerability that we find should be fixed immediately, but in the real world, we need to be able to do things like triage whether or not something actually is real or a false positive. And then people are busy, and what should they fix first versus what can maybe wait until the next sprint. So that we would describe as advanced detection. Moving forward, the next phase is enforcement and alternatives. Um, So can you actually start to get away from ad hoc scans or time-based scans, and can you start to get into secret scanning within the developer workflow? So what we would advise is, can you scan every commit? That way, when the developer is saving their work, they're going to get instantaneous feedback about something they need to fix. And providing that feedback at the right time is very important because it enables the developer to fix the problem while it's still fresh in their mind. When you force context switches on people, there's inefficiency there. But if I can give you immediate feedback that, hey, here's an issue, and you can go and fix it, you're just going to be able to fix it a little bit faster and easier. You don't have to remember exactly where it is or anything like that. The second thing is when that developer goes to actually merge their new code into the master branch, what are you doing to protect the main branch from those secrets? So do you have a mechanism that's going to automatically scan the pull request and give you the optional ability to block based on certain characteristics, like maybe the type of secret or the volume of secrets, anything like that? And then lastly, but again, not leastly, if now we're starting to get into the developer's workflow and we're starting to force them to change their behavior, can we give them an alternative? There are a handful of different ways to do it. In addition to secret management tools, there's also environment variables. But once I start enforcing things, I need to also start looking for alternatives, the way to do it, because there's a developer demand to write in those various secrets into code. So let me give them an easier alternative if I'm going to disallow them from doing that. And then lastly, and this is where what we think is the phase that we want everyone to get to, is you start thinking less in terms of finding secrets and you start thinking more in terms of risk reduction. So finding the secrets is a key part, but how exactly are those secrets going to get exposed? And we talked about this a little bit earlier, but it's the compromised accounts, it's the malicious insiders, and it's the source code leakage. So when you start to think about how am I going to deliver my organization a hard-coded secret solution, detection is actually really just one of a handful of things you should be thinking about. In addition to detection, you should also be thinking about authentication. You should be thinking about, am I able to apply and enforce strong authentication policies across all of the different systems in which my hard-coded secrets live? Can I enforce multi-factor authentication in the source control management system, in the build system, in my registry or artifactory? How do I actually do that? And if I do that, then I can make it much harder to compromise my developers' accounts. So that's a key part of this, right? We saw the tied for number one concern about secrets is actually preventing compromised accounts. So again, it's really important to think about, how do I actually apply those policies consistently across every place in my SDLC where secrets live. Second one here, malicious insiders. And again, this can be really tricky, but the way to think about this is, the ultimate thing is to have some type of anomaly detection. That can be hard to do, but one basic step that can go really far is to think about applying least privilege policies and actually enforcing those least privilege policies with regular excess privilege audits. So, again, it's about, can you create a policy of least privilege? Can you enforce it? And can you do it across all of the systems in which your secrets could possibly live? And then lastly, what are we doing to prevent source code leakage? This could take a number of different things, but we would recommend that you've got some type of alerting mechanism when when you see potentially suspicious activity. Potentially suspicious activity could be things like, it could be forking or cloning, although those are a little more regular possible behaviors of a developer. But you got to start asking yourself, well, if a developer is downloading source code, okay, why would they do that? And again, there could be legitimate reasons, but maybe at that point you might want to ask a question of why did you download? So alerting on potentially suspicious activity. But no matter what you do, some ability to be able to understand when your source code is exposed. Are you able to scan public code sharing sites like GitHub public repositories? Or even other things like SourceForge or any place where developers are possibly sharing code. So if you can get to this level where you've got policies in place, you've got advanced detection, you've got prioritization, you've got developer workflow integration, and now you're able to focus on risk reduction. This is where you can really move the needle within your organization. So with that, let's move on to our next poll.
So I've just launched our second poll. The second poll reads, what is your organization's biggest unmet need for hard-coded secrets? A, basic secret detection. We are just getting started. B, we don't scan for secrets everywhere in our SDLC. C, unsatisfactory scan results or too many false positives or false negatives. D, lack of developer buy-in. And E, overemphasis on finding secrets or lack of emphasis on risk reduction. So we'll just give that a minute or so we can get some responses in. And so far, our highest choice is B, we don't scan for secrets everywhere in our SDLC. And then our next two choices for the organization's biggest unmet need for hard-coded secrets, our basic secret detection and unsatisfactory scan results.
Well, should we give people just a little bit more to get their answers in, or does it look like most folks have gotten their answers in?
We've got about the same amount of responses on this one as we have the last, with the top answer still being, we don't scan for secrets everywhere in our SDLC. So I'll go ahead and close that poll.
All right, great. Yeah, I mean, that makes sense. Again, when we were going through the maturity model, we said we think that most people are probably in the basic secret, basic detection phase, and so it turns out we're probably right based on the needs of the folks in attendance today. Ronan, do you have any other thoughts on that?
Yeah, I think it's interesting to see that the scanning everywhere in the SDLC is something that people has in their mind. I think like the sort of the classic approach was to look at the code repositories themselves, and to me it's a good indicator that this is something that's on people's mind.
All right. Well, I think Ronan, I think we'll pass the screen over to you. Cody, do I need to stop sharing, or can Ronan just take over the screen?
So at this point, all Ronan needs to do is begin sharing his screen.
Do you see my screen?
We do.
Perfect.
Okay, perfect. Okay, so sort of the next section is about like how do you do secret scanning in a developer-friendly way, and we recommend sort of these 5 steps or 5 items to make sure that that you're aware of when you do this step toward reducing secrets exposure. So the first part would be obviously to involve developer in the choice of tools and working on a proof of concept. Eventually, they will be the main users of the platform. They're the one writing the code, and the problem is sort of the most severe in the code repositories. So having a buy-in from the developer teams and having a tool that really works with them would be the first step. Then we have prioritization, which talks about prioritizing the different detected secrets and allowing organizations to react to the secrets that are most important. Obviously, like if you have 1,000 secrets that were detected in a code repository, but one of them was detected publicly, you would want to start with the public one. Then we get to accuracy, which talked about the accuracy of the engines that you have running and looking for secrets. Timely feedback in the workflow, which means that you wanna help the developers as soon as it's possible, and having tools that can connect to the existing workflows that they use, so that when they commit a secret, it's immediately detected and they can react immediately, instead of them having to go back to something they worked on a while back and solving it later. And obviously having an efficient alternative, so having the ability to communicate to developers how they should treat secrets, how they should work with them, what tools they should use, what's the approach they need to take to handle the secrets securely. We have our last poll. Cody, you want to show it?
So I've just launched our final poll, but it reads, why do developers resist hard-coded secret solutions in your organization? A, there are too many false positives. B, too busy. C, it's not integrated into workflows. Or D, lack efficient authentication alternatives. So we'll give just a minute or so for these responses to come in. So far, our top choice with 44%, 46% of responses saying they lack efficient authentication alternatives. And our second choice, which is hovering just above 30%, says that it's just not integrated into their workflows. So I'll go ahead and close this poll with those two being our top responses.
So can you repeat the results again, Cody?
Sure. The top response was that they lack efficient authentication alternatives. And our second choice was they're just not integrated into workflows.
Okay, got it. Cool. So I think that shows that, like, first of all, the problem is important because it's not a prioritization issue, as well as we trust the engines. So moving on, we just want to double click like the main things to look for, when trying to do it the developer friendly way. So the first one is prioritization. So you need to be able to understand the secrets that you detect. So for example, whether the secret is something that is just a test secret or is it something that is used in production. You need to try to understand what the secret is used for. So is it for is it to access your cloud account or to a database or to an API, and maybe some specific APIs would be more important than others. So these are also things to make sure that the engines can look for. And then how likely is the exposure? So as a result of this secret being exposed in each repository, how many people can see it? Who has access to the source control? How strong is their authentication? If their account is compromised, will an attacker get access to the secret? And then be able to prioritize according to that. The next thing is accuracy. So there really is no one way to detect secrets.
and you need to use the right approach for the right secret. So basically, the first approach is to use known patterns. If you notice that GitHub changed their API and tokens permission, so the whole idea behind it was to add some kind of prefix to the secret so that you'll be able to distinguish GitHub tokens. So basically, when you look for secrets, if you know that the secret would have some known pattern that you can look at, or some known prefix or suffix, these will be the best things to rely on, and this will usually generate the least amount of false positive and false negatives. Then the next step would be to look at entropy-based detections. So we know that usually secrets, they would have a high entropy, meaning that they would have like different characters, and the characters themselves will be different from one another. So this is another thing that is good to look at. But in this case, it can generate a lot of false positive and a lot of noise. So you need to have also a mechanism around entropy-based detection that knows how to reduce this noise and knows to look at the context around the detected entropy and try to understand whether it's something that is related to a secret or just a high entropy string that is in the code base. And then we get to specific use cases. So there's often specific use cases when you use patterns. So for example, passwords, or in coding like username, passwords, in URL. So when you have this type of known scenarios, these are also things that you can use when you look for secrets, and you can build all kinds of detection engines around that. The next step would be to improve over time. So really give the developers and the users of the platform the ability to provide feedback and report false positive. And then obviously when something is reported false positive, learn from that, know not to alert on it in the future, and improve the overall false positive rate. And also accuracy, so correlate secrets across the different stages if you're able to detect secrets in other places than code. So we really look at which secrets were detected in more than one place. Obviously, this would be in higher severity. These will be the secrets that you want to handle first, and this will be also a very good way to know that you indeed found a secret and it's not false positive or false negative. The next thing is to have this workflow integration. So give the developers the right tools and alert them on the right secrets at the right time. The first reason is to eliminate the context switch the developers need to do if it's detected at another point in time, and then having them go back to some specific task, try to understand like what is the secret, why did they commit it, how they can overcome it and fix this issue, and protect the master branch or the main branch from developers committing secrets to it, because eventually this is the branch that everybody starts to work from, and you will want to make sure that no developer inherits secrets in the code that requires a lot of developers to fix it later, or some hardware fix within the SCM itself. Then if you look at workflow integration, so there are all kinds of places where you can come in. You can use a pre-commit hook, which basically runs on the developer's device and looks at commits the developers are pushing. So if you can block it there, this would be the best place. But this would also involve the developers having to run sort of the pre-commit hook as part of their environment. The next place to look for is integrating in the pull request. So if you couldn't stop the commit from going, make sure that once it is committed and the pull request is open, you alert the developer on the existence of a secret, and you also have the ability to block a pull request from merging if a secret is detected. So you can control how much strict you are with your secret policy. Integrate with alerting tools, so you can integrate to Slack or PagerDuty or whatever when a secret is committed, or when a secret is detected publicly, or in some other place that is more important to you. Open tickets from the platform. So for example, if you detect a secret in a build log, it's not something that you can comment in the code with, but it is a task that you would want to assign to your developers. So having this quick integration with the information that they need to fix it from your end. And when a fix is done, so really detect this fix, understand that the fix was made, and know to communicate it back to the developers, tell them that everything is okay, and that they can continue. And the last thing is obviously provide them with an efficient alternative. So, avoiding secrets entirely is not a really realistic option. The developers in the organization constantly change. You hire new developers, you train new developers. So you're almost constantly at the risk of having some developers that didn't go through enough training or is not experienced enough and might commit a secret to code. So really provide them with with a secret management solution or instruction on how to handle secrets. So for example, they can use environment variables for secrets. A better approach would be to use a secret manager. So for example, AWS offers ones, Google and HashiCorp is probably the most famous one. And then you also need to help them in the process. So have these guardrails in case that they still do this action, and connect with the pull request mechanism. Help them by scanning artifacts and making sure that they didn't export it there. Public storage places, public activity, and things like that. So we'll jump to a quick demo. So basically, this is the Cycode platform. Basically, the idea behind Cycode is that we're a software delivery pipeline security solution. We connect to the tools that make up your software delivery pipeline. So we start with the source control tools that you use. Larger organizations tend to use more than one, and this could be both cloud tools as well as on-prem instances. So in the code tools, you manage the code, you manage the distributed activity of our developers, but then usually you would have the tool that builds the product, so the tool that sort of connects to the source control, and then on specific action triggers a build workflow that pulls the code, does the build, and eventually takes the output and stores it in what we call a container registry. So this could be things like Docker App, JFrog, and other tools. And then finally, you would have your production environment that pulls from these container registries and runs the code that was built by the code that you have in the source control. So really, we connect to the tools that make your DevOps pipeline, and we have all kinds of security policies that we've built around that, mainly focused on preventing code tampering, securing your software supply chain, and preventing leaks. Then we also offer integration with alerting tools and issue tracking, where alerting is a way for you to get directly the alerts that come from our platform. So you can connect it to your existing workflows. And issue tracking is the ability to open tickets directly from within the platform. So currently the platform is divided into policies, where secrets is one of the models that we offer. We can show you like the various types that we have, and you can control the severity of each secret according to how you see fit in your organization. As well as you can build specific exclusions around secrets. So for example, if you have some specific policy or specific repository or specific path or specific file name that you don't want to scan, or that that you approve according to your policies, so you can add that. And this would tie back to the issues that we discussed in this webinar. So having the ability to really tailor study according to your needs and to the things that you have in your organizations. So then for each secret that we detect, we show it here in the violation sections in the secrets part. Basically, the way that we do the secret detection is that in the initial integration, we scan the secrets within the tool. So for core repositories, we scan the commit history, we scan the real-time activity whenever a new code is pushed. We scan, for example, other places like a build log, like the Kubernetes cluster, and check if there are any secrets that are stored insecurely there. We look at the public activity of the developers. And basically what we do is we assign tags to each detected secret. So you can filter on tags in the secret detection over here. you have this and/or filter. So for example, if I only want to see the secret that were detected in an organization private repository, I can use these two filters. If I want to keep focusing maybe on a specific organization, so I can filter on that. I can continue to deep dive and select a specific repository or a user, or even a specific secret type from the type that were detected. And I can deep dive into each of these. So I can go into each detected secret, see the places that it was detected, and then better understand the exposure that I might have from having this secret exposed. And I can see all the tags that were assigned to it. So for example, I can look at this tag and I can see that this is something that was detected in the test file. So it's probably something that is less interesting for me to look at. But then the more interesting would be to sort of check if I have a secret that is in an organization repository that is also publicly exposed. So these would be the secrets that I know that are hosted in some public repository. And this would probably be the secrets that I would want to look at and solve first. We do the scanning in the common code hosting websites. And then finally, we mentioned the pull request integration. So for the secrets, we have this pull integration that is generic across the different source control tools. So it works with all the tools that you saw in the integration piece. Basically, the way it works is that if you enable this feature of scanning on pull request, you can define a threshold of when you want to block a pull request from being able to merge, and when you just want to notify the developers that we detected a secret. So again, you can make this workflow more developer friendly. You can select specific organization or specific repositories within an organization and turn it on in these places. And to make this workflow as friendly as we could for developers, we have the ability to turn this flow into interactive and give the developers also the ability to manage secrets and communicate back to us through the pull request mechanism. So this is an example of how a pull request would look. This is the pull request I opened, and I committed a secret in the form of a generic password. So Psycho detects the secret and commented to me that a secret was found and I need to resolve it. Then because I enabled the interactive workflow, so I also get options to communicate back to Psycho. So I can tell Psycho to ignore these secrets because I don't think it should be considered, or because it's something that I need for my work. I can tell them to ignore it once. I can tell them that it's a false positive, and I can tell Psycho that it was already revoked. And then if I simply copy and paste this hashtag, we at Psycho, we would catch this event. We would know to react accordingly in the pull request. So unblock it if it's needed. And then we make sure that we show you the developer activities that were made by our developers within a dedicated section in the platform, so you can monitor that, look at the secrets that they reported as ignore or revoked or whatever. Make sure that you review them and really have this visibility around this type of activity. So that's the demo. I think we can do some Q&A if you have a few minutes.
Sure. We actually do have a number of questions I can see that have come in already, but we'll transition over to Q&A. And if anyone has questions they'd like to ask, please enter them now. So the first question we have here is, how is the scanner identifying something as a secret? And then it says if this is all regex based. So I think I would maybe repackage that question, Ronan, and say, can you talk about the different types, the different ways to find, to identify secrets, and what are some of the pros and cons of each approach?
Yeah. So basically, regex is the approach that is used when it's a known pattern of secret. Again, when this is possible, this would be the best approach to take because it has the lowest false positive rate and false negative rate. But then you would also need obviously other engines. So we mentioned two in this webinar. The first one would be entropy based. So really detecting high entropy strings, which would in many cases be related to some kind of secrets, but in many cases they don't. And because this could generate a lot of noise, so when you build such a entropy-based engine, you need to be able to look at the contents around detected high entropy strings and really understand if it shows like all kinds of indicator of a secret. So this will be a complementary engine to the first one, which is regex based. And then the last part would be to look for things that are more patterns. So if you think of passwords, so password, like there's no specific pattern to the password itself, but in many cases there would be like a pattern that developers use when they use passwords in code. So really looking into these types of cases, and again having the ability to remove false positives and false negatives from the detected data.
So the next question is related. It's what's the best way to handle false positives? And it says because everyone has their own definition of what it could be for their products or repos. And I think the answer to that one is that you need to make sure that you've got good feedback loops. So very few security products are going to be perfect right out of the box, but the better ones have the ability to get smarter. And so I think at a minimum, being able to give your developers the ability to mark things as ignore or false positives, and ideally to do that again right within their workflow so that it's easy. Because you might know something's a false positive, it might annoy you that it's a false positive, but if you got a context switch to update the system, people are busy and they'll just move on to the next thing. So the point is make it as easy as possible to get that feedback into the system, which at least from my purview and what I've seen work is to put it right within the developer's workflow. Ronan, do you have anything more to add to that?
No, I think you phrased it perfectly.
Okay, so then the next question is, what will you suggest during the pandemic when segregation of duties will be hard to be enforced, at least before things are getting back to normal again? So, go ahead.
Yeah, I don't know if it's specifically related to the pandemic, but I think this whole trend of remote work. First of all, it confused everyone from their private life and their professional life. So I think it sort of increased the risk of having secret exposed in public activity, because developers that contribute to open source, they now they work from home and they do this type of work from home as well. So really having the right controls in place is something that we need to pay extra attention to because of this shift to work from home.
Yeah, I mean, the way I think about it is that I think that working from home has exacerbated a problem, but a problem that was always there. And the fact of the matter is that we are adding more and more tools to our SDLC every couple of years, and each of those tools has its own identity system. And those tools aren't designed to talk to each other. So, for example, GitLab doesn't control the identity of JFrog. So how do we centrally manage and apply good governance policies across all of the tools? And when you think about all of the tools, at least from an enterprise perspective, it gets complicated pretty quickly, because not only do I have multiple tools within any one individual software delivery pipeline, in larger organizations, we've got multiple teams, and those teams very well may have their own sets of tools. Those sets of tools could be multiple instances of the same tool, like maybe everyone uses GitHub, but they've got their own instance. That becomes more difficult to manage. Or you've got GitHub and Bitbucket, because each team was given the ability to choose the right tool, for their job. And then you mix in the fact that kind of in enterprises, nothing ever really goes away. So, most larger organizations do have legacy apps that they maintain. And, that could be using, non-Git based stuff. It could be using Subversion. So now I've got a whole nother different types of systems that I'm using. And of course, within software, one of the things that we as an industry do more than anyone else is we acquire each other. So it's not just what do you have today, but what are you inheriting? So it's a pretty significant challenge, actually. And we would suggest, that you do need a platform to manage something like that. Cody, I know we just hit the top of the hour. Do we have time for any more questions?
It seems we're going to have to cut it short today. I'm sorry about that. However, if you have any closing remarks, we can go ahead and go through those right now.
We'll just say thanks to everyone for showing up. We think this is an important topic, and if there's anything that we can do to help, we're more than happy to cover any of this material again with you, or answer any questions that you have offline.
Outstanding. Well, as we are approaching the top of the hour, if there are any questions that we did not address today, we will be sending those over to the folks over at Skyrocketing, and I'm sure they can get those answered for you after the fact. Quick reminder that today's session was recorded, so if you missed any or all of the event, or you would just like to rewatch, it will be made available soon. Following the webinar, you will receive an email with a link to access the on-demand, or you can find the on-demand living on the devops.com/webinars. Look in the on-demand section. Now on to the 4 winners of our $25 gift card drawing today. Our first winner is Kawami A. Kawami A. Our second winner is Johan K. Congratulations, Johan. Our third winner is Pan K. Congratulations, Pan. And our fourth winner is Nordia G. Congratulations, Nordia. And our 3 other Amazon gift card winners. Keep an eye on your inbox. And if you do not receive an email, just check your spam folder. Ronan and Andrew, again, thank you so much for taking the time to put together this program and demo. I'd also like to thank you, our audience, for being with us for the entirety of today's presentation. This is Cody J. Brown signing off. Have a great day, everybody.
Thanks, Cody.